Hi, we are the team number 3, exercise 3, activity 7. The team is Alberto Vázquez, Emiliano Chaires, Paul Farias, and Arturo Garcia. We are going to resolve this problem that says obtain the following inverse Laplace transform of this equation. We are going to resolve this by partial fraction expansions. To find the constants, we separate this equation in this a over s plus b over s plus 1 plus c over s plus 1 raised to plus ds plus e over s plus 2 raised to plus 4. To resolve the constants, to resolve the a constant, we put limit when s tends to 0 and when we substitute the s, we obtain the constant a, and the same with the constant c is equal to s when s tends to minus 1. So these terms are cancelled, and if we substitute, we obtain 1 minus 1 over 5. For the term of b, we are going to put limit when s tends to minus 1, derivative of the function because it's a repeated term. So these terms are cancelled, and when we substitute and resolve this derivative, we obtain that b is equal to minus 8 over 25. For the last partial fraction expansion, we have these three constants resolved, and for resolve the last one, we put d is limit when s tends to 0, that the function multiplied by s. So when we divide the higher coefficients that have s, we obtain that this part is a plus b plus c plus d, because we have d over 1 in this part, and we result in this equation. So if we clear the constant d of this equation, we obtain minus a minus b, and this is equal to minus 1 over 4 minus 8 over 25, and this is equal to 7 over 100. So the next thing that we have to do is obtain the e constant. This is result when the limit s we have that e is equal to limit when s tends to 0, in order of this division don't be improper. So when we substitute all the terms, we have a plus b over 2 plus c over 4 plus d over 13 plus e over 13. So this is equal to these operations, and if we clear the constant e of this, we obtain that e is equal to 4 over 25. So only for say this result is this result is a consequence of the substitution of s when s tends to 1 of the first equation of the first function, of the first part of the partial fraction, and the result is 3 over 52. The next thing that I have to do is give form when we have the constants of the partial fractions. We substitute, but we try to separate the constants to the function that depends of s, and we have this in this part when, but in these steps that only we do is acquire the form to this function to in order of that of this function be more easy to resolve by direct formulas of the Laplace inverse. So in this part we have that the Laplace inverse of 1 over 4 multiplied by 1 over s is 1 over 4, and the same thing that this is minus 8 over 25 that multiplied 1 over s plus 1 is the same constant multiplied by an exponential raised to minus t. In this part we have a direct formula because we have the factorial number of alpha. Alpha is 1, and we have minus 1 over 5 multiplied t exponential minus t, and this part is more difficult because we need more procediment to resolve it. So we separate the constant of this part, and this part is going to resolve by the method shift. The method shift is suppose that in this part we not have a escurrimiento, and when we suppose that we need to evaluate at the end of this the escurrimiento, and the same thing is in this part of the equation. We have s plus 2, and this part when we get the escurrimiento is direct, but we need to put an exponential because this exponential is part of the formula, plus 1 over 100, the same exponential that is the same part, and sine of 2t. 2 is because 2 is the root of 4. And the next thing that we have to do is give form to this result, and we put the exponential that is multiplied these two terms, and it's the same for these two. We have 1 over 100 that is multiplied by this exponential and this, and we have this part of the result. Thank you.